3D printing's a lot of fun, and the equipment is now easier to use than ever before, faster, and more affordable. On top of that, there are so many great 3D models available over the internet, a lot of them for free. These are designs that may provide utility, entertain, or just create nostalgic collectible items for you. If you want to take 3D printing a step further though, it may be time to start designing your own 3D prints. What if you have a unique requirement that you can't find a 3D model for? Well, that's what we'll be diving into today. How to easily design and model your own 3D prints. Hey, this is Rohan here, and as mentioned, today we'll dive into using free 3D modeling software to easily create your own unique 3D prints. I'll take you through the process of sketching your design, downloading the free 3D modeling software, and some quick tips for navigating and using the software, then lastly, slicing and printing our design. If you like, feel free to follow along with this video, and at the end, you should end up with your own file that you can 3D print. There's a link provided in the video description though, in case you just like to download and print this 3D design. I apologize ahead of time if the pacing of this video is a little fast, but you can easily pause and rewind if needed. I just wanted to condense this lesson as much as possible so that people will stay engaged throughout. So let's get into it. The design we'll be creating is a pretty simple phone stand, so this will be a functional 3D print that you can get use from. We'll start off by sketching our design to establish as a guide, and your sketch doesn't need to be pretty, just as long as you can understand it is fine. So I sketched my design using an existing phone stand that I already own, and I took some measurements so that I could recreate something similar. One thing my existing phone stand was missing though was a pass-through hole for cables, so I went ahead and added one to improve on this design. This is the great thing about 3D printing. You can literally create objects to suit your specific needs. Okay, so now we've got our sketch done and it looks good, so what's next? Well, now we can move on to downloading our free 3D modeling program. The 3D modeling program we'll be using is Fusion 360. It's the free version available from Autodesk and perhaps the most popular modeling program amongst 3D printers. So to download it, just head over to autodesk.com, select Fusion from the Products tab, then click the Download Free Trial button. Then select the Autodesk Fusion for Personal Use Limited Version option and click on the Get Fusion 360 for Personal Use button. The website will take you to another window, which is a little redundant, but it highlights the differences between the free and paid versions here. I found that this version suits my needs well, and I haven't run into obstacles so far that this program can't handle. So we'll just click the Get Fusion 360 for Personal Use button again, then register or sign into your Autodesk account, and the download will become available. Simply download and install Fusion 360, then perform any necessary updates and you're ready to start 3D modeling. So now that we've got our 3D modeling program installed, is there a big learning curve to get used to before we could produce good 3D models? I'd say no actually. Fusion 360 is very easy to use. As a matter of fact, I really like Fusion's interface compared to other CAD design softwares that I've used previously. To me, it's a lot simpler to understand, is clean looking, and is very easy to navigate. Here's a few quick tips for getting started with Fusion 360. By the way, if you're already experienced or consider yourself to be an expert in Fusion, you probably won't find value here. But for people that are new to this program and maybe 3D printing, there's plenty of valuable information in here. Also, I don't claim to be an expert on Fusion 360, but I'm pretty comfortable with the program. If you consider yourself an advanced user and have some valuable tips to share, drop them in the comments below. It'll help others and even myself out. I'm always looking to learn and become better. Moving on though. So when we first open Fusion 360, you'll be greeted with this window. There's a few main areas that you should be aware of. First off, there's the application bar section in the top right, which allows you to open and save different versions. There's also the toolbar below, which gives you access to all the different tools, as well as a drop-down menu so that you can select different types of workspaces. We won't worry about workspaces too much for this video, but maybe in the future I can go over it in more detail. By the way, I've linked the product documentation for Fusion in the video description so that anybody who's interested can check it out. The product documentation gives a thorough breakdown of all the program features, and it has lots of visual aids so it's easy to understand. Moving on, below the toolbar is the browser, which shows you the organization of objects inside your model. Below that is the timeline where Fusion saves your modeling history, so you can actually step backwards and change or adjust things without undoing the progress that you've made. Just above the timeline is the navigation bar, which has commands to zoom, pan, and orbit your design. There's also display settings to control the appearance of your design here. Lastly, we have the assembly window or canvas in the middle of our screen, where we'll create our design. Now that we have a basic understanding of the interface, we're almost ready to begin modeling our design, but first we just want to make sure that we're using it, and we could do this by clicking the Profile button and selecting Preferences, then selecting Design from the Default Units dropdown, and make sure that it's set to millimeters, which is what we'll be using for 3D print modeling. Okay, now we're ready. We'll start off by first creating a 2D sketch, which is the foundation for building 3D models. When I click on Sketch, you'll see that the plane selections pop up. So I can select either the X, Y, or Z plane to begin sketching on, and depending on my model, I'll want to select the one that makes my workflow easy. For my particular model, I'd like to start off with the side view, then extrude from that. So I'll select the Z plane and begin my sketch. This takes us into a flat two-dimensional view so that we can begin drawing. Notice that our set of tools in our toolbar has changed as well. This is known as the contextual environment, which varies depending on the contextual tab that we've selected. So to elaborate on the toolbar, which we're currently using, it contains workspaces with the workspace picker drop down to the far left and tabs to the right. These tabs are the ones labeled solid, surface, mesh, sheet metal, plastic, and utilities. Underneath each of the tabs, for example solids, you then have the contextual tabs like create sketch, which is what we've selected, or you can also select extrude, revolve, and so on. Selecting a contextual tab is what changes the toolbar menu to display a different contextual environment. I apologize if this is getting a bit technical, but I want to explain properly what's going on here. To put it simply though, you have tabs and sub-tabs, which then displays different toolbar menus depending on the sub-tab that you have selected. Moving on though, let's start out drawing our sketch. So I start out by selecting the line option, and this is under the Create Sketch button found in the Solid tab. So I'll start by clicking the origin point, moving the cursor so that it snaps to be horizontal, then typing 93mm and clicking Enter. I'm just following the lines and dimensions from my sketch and roughly guessing the angles of some of these lines. Don't worry, it doesn't need to be exact right now, and we could adjust the angles afterwards if necessary. By the way, it'll be quicker to navigate using shortcuts, and you can find the shortcut command by hovering over the action or button that you'd like to use. So for our next line, I'll just type the letter L on my keyboard and draw a line connecting to our last one's endpoint. I'll type 90mm for the length, then press tab to jump over to the angle and type 115 degrees. My next line will be 73mm with the angle of 120 degrees, and the last two lines I'll type 18mm for the first one, then move my cursor until the line snaps to be perpendicular with the one I just created, then I'll do the same for the last one. I'll type 9mm, then move my cursor again until the line snaps to be perpendicular with the one I just created, then press enter. There, now we have our basic shape to build from, so we'll just press the finish sketch button to finalize our actions. Now we can move on to extruding our 2D sketch, and this is where our model starts to take shape as a 3D design. So next, we'll select the Surface tab, then click the Extrude button. The view cube located in the top right is great for quickly snapping to different view angles while working, so I'll click on the corner of the cube to get a better look at my model. Notice that you can click and drag the arrow in either direction to extrude the sketch, but I'll just type a specific value instead, which I've decided to be -68mm. I'm using the minus value so that my sketch remains at the front of my model, and so that I can continue working in the orientation that I started in. So next I want to cut out notches from the model so that cables can be inserted into the foam while on the stand. So I'll select the Create Sketch option underneath the Surface tab, then click the planar face that I want to sketch on. I'll first sketch a couple of lines that are 12mm from the edge and use this as a guide based on the sketch I've drawn. I then type R to use the rectangle tool, enter 44mm, then press tab and enter 9mm to cover the area that I want to remove from my design. I'll also delete the lines that I'd made as guides as they're unnecessary. To remove this newly drawn sketch from the design, select the Solid tab, highlight, and then click the sketch, then click the Extrude button. Within the Extrude menu, change the direction option to be symmetric, the distance option to be 1mm, and the operation option to cut, then press the OK button. You should see that your new sketch has been removed from the body of the model. I then repeat the steps for all of the surfaces that I want to notch out. For the oval hole in the back of the model, which will be our cable pass-through, I draw a line from the dead center of the top of this planar face, measuring 28mm, then select the ellipse option from the Create drop-down menu. I center it up, type 26.5mm, left click, then type 34.5mm, and left click again. After finishing the sketch, I move the ellipse to meet the bottom of the line that I drawn previously, making sure that it's centered. Then I delete that line as I won't be needing it. Once done, I perform a cut extrusion, same as I'd done previously. Okay, now we pretty much have the shape of our phone stand, but it's thin and has very sharp angles. So we'll thicken it and add some nice round edges to finish it up. So I'm going to click the right side of the view cube to get back to our two-dimensional view for a sec. I then select the solid tab and type F on my keyboard for the fillet menu. Then I click on the line that's the back of our phone stand to select it as a face and type 5mm, leaving the other values default. If you go back to the angle view, you'll see that we now have a couple of nice rounded edges. So let's get the rest of these corners rounded as well. So for the rest of these edges, I don't want them to be quite as round, so I'll just type F again, but this time in the 3D view, click on the specific edges that I want to round. You can see that I have 4 edges selected here. Then I'll type 2mm as the value and press OK. Lastly are the hooks and the little notch towards the bottom of the backrest. For these I'll select the surface tab, then click create sketch, then draw a rectangle overlapping the previous sketch, but we'll add fillets to the corner of these sketches, then extrude them shortly. Okay, we're close to done now. I'm just going to thicken the model, then put finishing touches on it with a few extrusions and fillets. Click the solid tab, then select thicken from the create drop-down menu. Click on the model, then enter a value. I enter -4mm to thicken the outside of the model, ensuring that the direction is set to one side and that the operation is set to join, and then I press the OK button. This ensures that my phone will fit comfortably inside the hooks. So now I'll just jump back to the previous sketches that I've done with fillets and extrude them to round some of these remaining corners. One thing that bugs me a bit is that the base is no longer flush after thickening the model, so I'm just going to fix that quickly, then round the corners. Feel free to skip this part though and just round the corners if you like. So I'm just going to click on the solid tab, click extrude, select the planar face, then rotate to the bottom view to get a precise look. I'll type 1.65mm, making sure that the operation is set to join, and press enter. I'll then perform a surface sketch and add 4mm fillets to each corner and perform a solid cut extrusion after. Okay, so we're basically 99% done. Lastly, I'll just add a 1mm fillet to the edges, save it as a 3D print file, and send it to my slicer program for print. Oh, I'm also going to rotate this model 90 degrees onto its side so that when I open it in my slicer program, it's already in the ideal print orientation. Fusion 360 has an export for 3D print option built into the file menu, so it's really easy and convenient. Just click on the model, select your format, I'll use STL, make sure that the unit type is set to millimeters, and for refinement, I have mine set to high. So just press the OK button, select your save destination, create a file name, and you're done modeling. So now I'll just load it into my slicer program using Bambu Studio. Looks good. Okay, I'm just going to add some supports for the overhangs, then send it off to print. I'll use tree supports and the default settings. Okay, so the print took a couple of hours and it came out looking great. So there you have it, a simple yet functional model designed from scratch, then 3D printed. We covered roughly sketching your design on paper, downloading the free 3D modeling software Fusion 360, tips for navigating and getting familiar with the Fusion interface, step-by-step instructions for modeling this phone stand using Fusion, exporting your model, then adding supports and 3D printing using a 3D print slicer program. I hope that this instructional video was simple and easy to follow along with as intended, and that you got some value from it. If you got any valuable tips that you'd like to share for using Fusion 360, please drop them in the comments below. Also, let me know what you thought of this type of video, and if you'd like to see more instructional content covering Fusion 360 or Bambu Studio. Oh, by the way, thanks to everyone that participated in my recent survey. So I put a survey out asking which 3D printer people thought was a better buy between the Bambu Lab A1 Mini and the Anycubic Cobra 2 Pro, and the response heavily favored the Bambu Lab A1 Mini by 83% to 17%. So we have a clear winner here, and the survey was to help me decide which 3D printer to get as a substitute, while I await a replacement heatbed for the A1, but it's close enough now to the date that Bambu Lab stated they were planning to ship them out, and I reflected a bit and came to the realization that there's still ways to stay engaged with 3D printing, like by continuing to practice and develop 3D modeling skills such as this, and I can continue to create content for this channel by publishing that sort of material in the meantime. So I'm just going to play the waiting game for now. If you enjoyed this content, please check out my other videos, and don't forget to hit the like and subscribe button and turn on the notification bell so that you can be informed when new videos are released. Links can be found in the video description for the 3D print and featured programs. Any affiliate links used helps to support this channel at no extra cost to you, of course. Thanks for watching, and until next time, see you then.